Hello students, how are you? Hope you're doing well. Now the question is, explain briefly how part 1 barrier potential is formed in PN junction diode, and part 2 width of the depletion region of the diode is affected when part A forward biased and part B reverse biased. So the problem is based on the topic PN junction diode, and in particular how the barrier potential is formed. So for that, first you have to draw this particular diagram showing the p-type semiconductor and n-type semiconductors. In the p-type semiconductor, there are negative ions. There are negative ions. There are majority charge carriers as holes and minority charge carriers as electrons. For the n-type of semiconductor, there are positive ions. There are majority charge carrier as electrons and minority charge carriers as holes. So when this particular diode is formed with the help of certain manufacturing techniques, the manufacturing techniques of the diode, then what happens that at this particular junction, the charge carrier, the majority charge carrier will try to move from one side to another side due to the concentration imbalance. For example, the holes are more in the p side, whereas these are less in the n side. So by the diffusion process, they try to move from the p side to n side. Similarly, the electrons are there, which are in the bulk amount in the n type of semiconductor. They try to move towards the left hand side region. So in this process, when they try to move across this particular junction, they recombine with each other. And when they recombine with each other, they produce energy and it disappears. When the charge carriers, holes and electrons, they recombine, they disappear and energy is produced there. So in this way, we can say that the near the junction region, there is a scarcity. There are less number of charge carrier on both sides. So in this way, we can say that this particular layer consists of mainly ions. The layer near this particular junction, the layer of ions, it corresponds mainly the void of charge carriers. There are very few charge carriers. Mainly there are ions. So these particular ions, they create the depletion layer. So this is the particular depletion layer here, which is also called the barrier region. So this particular barrier region, it creates a certain potential because the left hand side there are certain charge carriers, there are right hand side there are certain charge carriers. In the left hand side there are holes, in the p side there are holes mainly, and in the right hand side there are electrons mainly. So it is a kind of a plate, the positive plate and the negative plate, and in between there is a kind of a insulating layer, a depletion layer having the insulating properties. So this particular depletion layer, it creates a barrier potential. So this is the explanation of the first part of this particular problem. Now the second part, width of the depletion layer, about the width of the depletion layer. In the case one, when this particular diode is applied by a forward bias. Forward bias means battery is positive is connected with the anode side and battery negative is connected with the cathode side. Then in this particular case, what happens that this depletion layer becomes thin. So we can say that the width of the depletion layer reduces. The reason being that this particular battery provides a supply, it provides an attraction for the electron of the n side to move towards this, and this negative terminal, it attracts the holes from the left hand, that is p side, to this particular terminal. So in this way they crosses this junction, and when they crosses this particular junction, the uncovering of charge carrier, uncovering of the ions, it reduces. It means that the depletion layer becomes thinner. This is the first case when it is forward bias. But when it is reverse bias, for example, it is reverse bias. So what happens when it is reverse bias? Then in this particular case, this is the negative terminal here, this is the positive terminal here. So the negative terminal will attract the positive charge particle, which is the hole in this particular case. Hole will move towards this side. Electron will move towards this side because this is the positive terminal. Electron is a negative charge particle. So in this way, these charge carrier move away from the junction. In this way, we can see that the junction, the depletion layer, it increases. We have to answer only in a few words that in the forward bias, the depletion becomes thin, and in the reverse bias, the depletion layer becomes large. That's it. But I have explained also the reason why it is so. So hope you understand the solution. Thank you.